So here's number 2 of our 3 types of designs. We did the randomized, and then now we're going to do matched pairs. So randomized, we randomly looked at it. Matched pairs, guess what? We're going to match them up. A matched pairs design is an experimental design in which the experimental units are what? Paired up. Oh, that's not helpful, is it? Are paired up. They're matched. The pairs are selected so they are related in some way. That's important. There are only 2 levels of treatment in a matched pairs design because you have to be able to match them up in a pair. That's the key there. All right. So here's a matched pairs design. This is what it looks like. An educational psychologist wants to determine whether listening to music has an effect on students' ability to learn. All right, so they want to know, am I listening to music? Am I not? Design an experiment to help the psychologist answer the question. So the first thing that we're going to do is match students according to gender and IQ. And the point of that is just making sure that we take out any, do boys study different and learn differently than girls, right? I mean, there's tons of studies on those kinds of things. So that's why you're matching with gender and IQ. I'm trying to say, okay, if I have a higher IQ, is it going to make an impact versus a lower IQ, right? So you don't want to have too many extra variables in there. So whenever you match your students up, you want to try to get them related in some way, right? That was the point of this, related in some way, so that I take out all the extra factors, if at all possible, so that I can focus on the music aspect, because that's what he really wants to do is listening to music affect the ability to learn. That's what I want to do. This is what I want. So I don't want any extra factors there. So I try to match them up so I don't have that. Then you randomly assign a student from each pair to a treatment, and then you administer treatment. So whenever you have this and you're matching this pairs up, you basically have 2 boys who have an IQ of the same number, right? Whatever that number is. Low IQ, high IQ, doesn't matter. So 2 boys, same IQ. One of them gets music and one doesn't. One music, one quiet, right? However you want to say that. That's the matchup. 2 boys, same IQ, one gets music, one doesn't, all right? Then you administer the treatment, the exact same thing to both of them, so they're studying the same subject. They're going through the same homework. One's listening to music, one's not. For each matched pair, compute the difference in the scores on the exam. So once they take this test, how is that affected? That's a matched pairs. That's what that means. So basically, as similar as possible. Twins work great for this, right? They do a lot of twin studies with matched pairs because you try to get as close as possible. And then what happens to one versus another. And so then you can match them up and see how it's truly affected. Cool, right? Matched pairs. That's awesome. The very last one we're going to talk about is block. The block design. So, grouping together similar, and we call that homogeneous. Homogeneous. So that means similar, same words. So those are synonymous. Experimental units, and then randomly assigning the units within each group to a treatment is called blocking. All right, so you want things that are very similar, but you're going to group them into a block this time. So I'm going to look at things in terms of a block. So a block is each group of homogeneous individuals. A group of homogeneous individuals. Right, so things that are the same, but I want to block. So if I'm going to group things together and block them together, then I'm going to use what's called randomized block design. Is used when the experimental units are divided into blocks. Whoa, my thing is moving on me. And remember, a block, because I want to make sure you understand a block is similar individuals. So when we divide it into a block, we're dividing it into groups that are very similar. So we have completely randomized, so individuals are randomized. We've got the matched pairs. You match up things that are closest possible. Then randomized block means I have groups. And then it has to stay within that group, but then that group is randomly given the treatment, whatever that is. All right, so let's go back to the soybean plants. Suppose that 60 soybean plants are actually 2 different varieties. So 30 Kim-Grow soybean plants and 30 Pioneer. So I have 2 full groups. So they start with 60 plants. 30 of them are Kim-Grow, 30 of them are Pioneer. That's how you block it up. If they were all the exact same plant, you go with completely randomized design. When you have groups and blocks, they're called of the same thing, then I'm going to take this block and do the exact same treatment that I did before, but I'm going to split up with this block and figure out how much it is. Then this totally separate type of plant, I'm going to split up, do the treatments, and figure out what it produces. Do you see how that's different? So the randomized block design means I have a block and then I do the full experiment on each block is how that plays out. If it's completely randomized, then I'm doing the experiment on the individuals at that point, but the block means I do the experiment on like basically two separate experiments because I have 2 different blocks. All right. Yeah, you guys did it. That's chapter 1. You made it. You're doing great.